live. Are we live, Sarah, on everything?
Yep.
Oh, awesome. Well, hello, everybody. It's Chris again, and thank you for jumping in and joining our live. Appreciate that, especially on a Friday. So today we're going to be talking about something that we typically use almost every day, and that's our range. And most importantly, we're going to be talking about elements, the different style of elements, and really want to kind of be able to show you how you, well, I guess one, so you understand how the element works, and two, how you can test it in case you're having a problem, so you know whether or not the element's at fault, and to be able to recognize the different types so you know what it is you're going to be working with. So here on the table right now we've got what we call surface elements, elements that where you set your pots, your fry pans, whatever, on your cooktops. So we've got the old tried and true coil element. A lot of us are familiar with that. That used to be the main and only style of element that range has had for a lot of years. And then as technology changed, we started seeing some other types come along. And the biggest and most common is what we call the radiant element. So this funny little pattern you see is actually the element itself. This section here is twofold. It's a thermostat and it's a switch as well. And it has two purposes. So we're going to explain all what that is as we move along through our live today. But so just want to, remind everybody that if you have any kind of questions that you want to ask regarding ranges, elements, or any other appliance, we're here for you. Just put it into your comments. And Sarah's here, of course. Say hi, Sarah.
Hey, everyone.
So Sarah's running mission control, and she will pick up your questions and pass them along to me. And we'll do our best to try and answer them for you. So, and of course, if you will get this out of the way, the usual, if you do like this video, by all means, don't forget to give us a thumbs up. And for sure, if you'd like to see more of this type stuff, don't forget to subscribe. And for all our fans, whether it's TikTok or YouTube or whatever platform you're seeing us right now, please don't hesitate to do that subscription thing so you can see us every time we're doing these lives or any videos we're putting out. So let's talk about the element again a little bit. So I mentioned that this is your common type that you see in most smooth top ranges now. And they come in different sizes. Just like your typical burners, when you look at your smooth top, you can see by the rings on the top of it, the basic outline of your size of your element. And of course you've got that little decal on the top of the glass that tells you the size of your element. But the thing that's kind of neat about them, if you were to look at this one, this small one is basically one wire. See if I can show that to you. Get it lined up here. Bear with me. Right. So there's one wire that comes in right there, and then it moves through the center and feeds back and forth all the way till it gets to the outer edge, and then as it reaches the outer edge, it makes its way to come back out of the element to where the wires would connect. So between the wires and the actual heating element is that thermostat I was talking about. So this one's kind of important because this is a real common issue that a lot of people face with their smooth top stoves. And I'm going to show you the similar type element as this one, but a different color insulation and stuff. But this one has the cover removed, from the switch. So what you see in there, try and get it as close as I can and lined up for you. Sorry if anybody gets motion sickness. There we go. So there's actually two sets of contacts in here. So this rod that goes through the middle of the element is a glass rod with a metal piece inside that's actually two dissimilar metals. So when you bond two dissimilar metals together, they expand at different rates so that when it heats, it'll expand. So when this rod expands, it operates the contacts here in the switch box. So in a situation where your element is overheating, it will, through this sensing rod, expand and push on the contacts, and it will turn the element off, even though the switch where you select your temperature is still turned on. This will open up the circuit, allow the element to cool, and once it cools, it will close the set of contacts and the element will come back on. So this is a safety feature, and if your element is starting to cycle on this safety feature all the time, it's a sign that the switch where you control your temperature is starting to fail, because it should be controlling your temperature, not this. Now, the other thing that'll make this trigger is if you're using a pot on your smooth top that's perhaps the wrong size for the size of the element you're using. So if you've got a really large pot on a small element and you've got this switch set for, high so it'll boil, you can actually be overheating this element for what it's designed for. So this little device will be your safety feature, and that will save your element from overheating, and it'll protect the glass from breaking from overheating or thermal surge. The other set of contacts that's in here, and this is the one you most commonly see being a problem, is the one for the hot light on your cooktop. So when you turn your burner on, the burner comes on, starts to get warm on the cooktop, and instantly you see your hot light come on in your console or on your glass top to warn you that there is a hot surface. So if you find after you've used your cooktop and you've turned it off and everything's nice and cold, but the hot light is still on, this is typically your problem. This set of contacts over time will wear out and they'll stick. So if that's the case, you're looking at replacing a part. Now, some of these elements, you'll see where this thermostat mounts has a couple of screws. Yeah, there we are, trying to do the dance again. Right, so there's the screws. So that means that this switch can be ordered separate and can be replaced separately by simply removing those screws and sliding it out of the element and put your new one in, reattach the screws, and put it back in place, and you're good to go. Now, something that's really important with these, and we're talking about stoves you see today with this style of element that has this type of switch that controls your element. This is what's behind the console where your knob goes on and you turn it for high or somewhere in between. So what this guy does is basically turn the power on and off depending on usage. Now this switch is rated to this element. In other words, if this is a 2000 watt element, this switch has to be designed to handle a 2000 watt element. So you can't really just mix and match elements or mix and match switches. In today's world, there's really no universal switches that you can replace if they fail. You need to use your model number and use the exact model number and series number, and in some cases the manufacturer requires your serial number. But it's just that easy to go on the website and put in your model number, find out which switch you have that you're looking for, identify it on the parts breakdown, and sometimes you have to look to see for which burner it's for and what the wattage is, so you make sure you get the right one. And then just put it into your cart, go through the process, and it can be sent right to your home. But this is the most common thing that's a problem with your cooktops and your stoves. These switches in the element, and sometimes the element will fail. It's not super common. In fact, most manufacturers used to warranty these elements for 5 years. Some of them are even more. But that's what you'll find under your glass top, and that's your typical element. And again, there's different styles. This one's kind of neat. It looks a lot like the one I just showed you. The difference is this one has a very low wattage rating, which is very hard for you to see the numbers on the back, but this is actually only rated for 100 watts compared to, say, this, which is 2,500 watts. So this little guy only being 100 watts, which is, you think about a 100-watt light bulb, this produces the same amount of heat as a 100-watt light bulb. And if you look at the information on the back, it'll actually tell you it's only a 110-volt element, where these ones, your main surface ones, are always 220 volt. So why would I have an element on my cooktop that's same size as the other small element, very low power output, or power consumption, sorry, and only running on half the voltage? So this is on a stove that has a warming element on your cooktop. It's designed simply to keep the teapot warm. Maybe you've got a casserole dish that you're just looking to keep some heat onto so it stays warm while the rest of the food is being prepared. So they use a different style of element, and again, it runs on a different voltage and it's a very low wattage. But if you were to try and just go pick up an element somewhere and say, oh yeah, I just need a 6-inch element, and here's, without having the actual part number, you could be getting the wrong element and it's not going to work. So you always want to order elements with your model number. That's just key. Otherwise, it's an electrical part, so you do have to be careful when you buy electrical parts, because they may not be too keen on taking it back if you've already installed it. So, anyway, that's kind of like the elements we see today. That's what's on most smooth top stoves, which is typically the most common stove that's being bought today. But they're all the same design. This material is an insulation, and you can see this one is broken, and that's quite common. You do have to watch these as far as how you handle them. You'd almost have to consider this being fragile. If you bang it hard or drop it, this will crack. This, like I say, is an insulation, so if this separates or a piece comes out of it, we now have a heat loss spot, so you're going to get heat starting to weep outside the element, which can create a hot spot in your glass cooktop, which can eventually do a point where the top may crack. So that's, speaking of cooktops, since we're talking about this kind of element, if you have a glass top and all of a sudden you've noticed that it's got a crack and you didn't drop anything on it and the crack goes right across the top of the element in any direction, but there's a solid crack right across the element, that's typically a sign that the element has overheated, and it overheated the glass and the glass cracks. If that's happened, what you typically will see is you may have somebody coming to service it, or you may decide to replace the cooktop itself, which is not a bad repair to do. It's actually quite easy in most cases. The thing is, if you've had a thermal breakage or thermal crack because this sensor failed and stayed on, it didn't protect the cooktop, it didn't protect the element. If you put a new glass top on there, then this guy's still going to overheat and you could wind up just ruining your brand new cooktop. So if you're seeing a thermal break where the crack is directly across the element, you may want to consider replacing this thermostat when you order that cooktop. Order this thermostat, and if the thermostat's not available separate, order the element and change it at the same time, just so you don't wind up doing the same repair over again, wasting your time and spending a lot of extra money you don't have to. So say I think I have a bad element. The switch is on, the light's on, saying that there's power going to it. How do I test it to know if it's bad? Well, they're really easy. Elements are generally pretty easy to test. Whether it's a coil element like this or this style, testing is very, very easy. So, of course, you need to remove the power from the stove so you don't put your fingers anywhere where you're going to get a 240-volt shock, which is no fun whatsoever. And you need a multimeter. Now, multimeters come in two forms. This is an analog, which is basically has a needle that swings over and gives you a measurement. Or you can use a digital, which will give you a display. So this is a fairly expensive one. Meters a whole lot of things in various ranges and some auto ranging as well as continuity. This one does the exact same thing, but an analog needle sweep version. Doesn't cover as many ranges of things you can measure as the digital one does, but for most average use for doing appliances, this works well. And you can pick these up at your local hardware stores, and they're not super expensive. The digital one that does everything, that's pricey, but you can get this size in digital or analog, and they're pretty inexpensive. And to do the test, it's really cool. All you do is you take your device, you'll see on there that there's a setting for measuring resistance, which will be a little number with like an upside down horseshoe on it. And if you can see that, it will focus. So this is for our resistance. And you'll always see one setting that you'll turn that to. It looks like a little speaker, same as you would see like your speaker icon down on the toolbar of your computer. So with that setting right there, that's your best tool for testing your elements, because this does two things. If you were to touch these two probes together, which would be basically making a completed circuit, meaning you have continuity, two things will happen with these meters. One, you'll see the needle swing, he says, and we should be getting a beep. And this one's not doing that. Ah, there we go. So you can see the needle. See if I can get this so you can see it. The needle moves right across, showing that I have continuity, and we're getting the squeal from the meter telling us we have continuity, which is really helpful, because if you're doing a test and you can't see this screen, you can't see the needle move across, you know you have continuity because it's beeping for you. So let's test this element. I'm going to try and bring you a little closer so you can see what I'm doing here. Okay, so there's our element. This is where our wires connect. So this particular element has two different size elements in it. So this would be an expandable element. So what I mean by that, and for those of you who have them, you know, you turn your surface unit switch over to one side for the large, or you turn it to the other side, which is for your smaller element, or you may have an option where you can actually have both of them on at the same time for doing that really large pot. So maybe we have the outer coil not heating up anymore. The switch looks good, you know, everything's doing the way you normally set it up. You're just only getting the inner element coming on instead of the whole thing. So if we wanted to look at this outer element here, we're simply going to look at the tracking, see where the element goes. Comes out here. And the other side of it comes out to here. And there you can see our meter is fluctuating, and you're getting the beep. So I know that that circuit is good. That's not the problem. If I want to check the inner one, again, I'm going to go to the inner wire and to the common. And again, we have continuity. This element tests fine. So there's no reason there why this element shouldn't be working for you. And if it's not working and your switch on your console is on, then there's a problem. Now the problem might be, we know it's not the actual coil itself. It could be the thermostat that's opened up and not reset. And that's easy to test as well. We have one set of contacts. If I can find the one there without having this on. Let's do it with the one where we can see the contacts. So we've got this one here. So I'm testing from one side of that to the other. So this is where the wire from your range powers the element. It comes in through this switch and then feeds into the element. So that's good. So this element, there's no reason why it shouldn't work. So now you're going to go back and do our troubleshooting, and you'll probably find that your infinite switch that controls it is what's actually bad. So being able to test an element is really helpful. So if you understand that it's just basic continuity you're checking for, then you can diagnose any element to see whether it's good or bad. And if it's good, but you're still having some kind of a heat issue, then you know it's beyond that. It's probably the switch. Now, if we're using a digital meter, it's the same setup. We're setting our meter so that, get as close as I can, okay, where it says for buzz, as in Buzz Lightyear. Anybody who's a Toy Story fan knows who Buzz Lightyear is. Okay, so we'll bring our meter so we can see it. So we don't have that swinging needle, we have a digital display. So if I put my two needles together, again I get a beep, and I show that there's a tiny little bit of resistance there simply from the wires that are from the meter itself. So if we want to do our same test on the element and go across the coil, one lead on that terminal, one on the other side, and we're getting tone, and we're actually starting to read the actual resistance of that coil, which is 139 ohms. Okay, so whether we want to check the switch, just check the element, we can do that with a continuity test on our meter. And that's the same thing if we were doing this style of element. I'll move this one out of the way so you don't get that contrast in colors that makes it hard to see. So there's our element. These are the two prongs where the power goes in and out. And there you go. We have tone, and with our digital we can actually see the actual resistance of the element. No different if you were using this one. You can see the needle swings, and you're getting a tone. So you know this element is good. So that's your surface elements. So I don't know if we have any questions coming in, Sarah. Is it quiet today?
It's a quiet crowd.
Okay, well that's all good. So let's not worry about surface elements anymore. What's the other most important element in your typical range? Your oven element. And there's just about as many shapes and sizes of oven elements as there is cooktop elements. So this one, I'm going to move these up a bit. Hang on. Here we go. Try and get you lined up. There. Okay, so this is your typical broil element. You don't often get to see it because it's mounted up to the upper part of your oven liner. So you just know it's there and it heats, but you don't really get to look at it. But this is what a typical broil element looks like. It's a multi-pass element. It's got a metal framework that holds it together. It's got some extra tabs here for where it mounts into the top of the oven liner so it doesn't fall down. Then we have the bracket where it actually winds up being physically attached to the oven liner. And then we have our two leads that pass through the back wall of the oven, and these extend from the back wall to where your very back of your range is. So this is what's inside there. This is where your wires attach. And these ones are just spade terminals. Your electrical connection, simply the wire just pushes on, and that connection should be a nice solid tight connection. But again, it's a basic element. It's 220 volts on these, and again, if you're using your meter, same process. Bring your meter in. Let me get you lined up. There we go. And again, continuity. Put them on either end. Again, we have the completed circuit. So whether you're testing a bake element, a surface element, broil element, it's all the same process. You just need this handy meter. And again, they're not expensive, and you can get them pretty well any hardware store or electrical supply store. And again, once you know that the element's good or bad, then you're able to just simply, on your phone, on your tablet, on your computer, just go online. You can go to our website, put in your model number, search up your bake element. There's a parts breakdown there, and you can select the proper part for your range. And as well, you're most likely going to find videos on how you can remove and replace that element. And it really is a repair that you can do yourself and save yourself a whole lot of money.
We did a video before where I took out a range element, so if I can do it, anyone can do it.
Well, they are pretty easy to do, and you did an awesome job on it when you did it. So I just want to...
I think the hardest part was taking a door off the oven.
Yes. Yeah, and you can do most of them without taking the door off. It's just a lot easier with the door off to get in at everything. Alrighty. Okay, so this is a bake element. You can see the stature of it. It's fairly wide. There's an electrical connection on either side. This one would basically be in your oven and going through the back walls a great distance apart. This as well is a bake element. Same idea, it's simply a loop, and it has the push-on terminals as well, but you can see that the two legs that go through the back are actually close together. So they mount, this mounts to your oven liner, these go through to the back where your wires are, and very easy to change. Two screws that mount it, allows you to pull it out, and if the manufacturer was kind enough to leave you enough wire in the back, the wire will come out, and very easy to change it right from the front without having to move your oven. So I said that pretty quickly, but if you're not sure, check out our website. We've got several videos to show you how to change elements on your range, and you'll see it really is pretty easy to do. So we've all seen elements. We've all opened our oven door or used a cooktop and we've seen our element. But what is an element? Well, the black part that you see that gets cherry red when it's turned on, that's a metal outer casing. Inside is where the element is. And I'm just going to try and show you that little strand, if I can get the cameras to focus on it. It's a little hard to see, but there is a small strand. Oh, look at that. Sarah, you are the best.
That's what I'm here for.
So you can see that little strand? That's the actual heating element. That's what has the power going through it. So that's what turns this outer casing, cherry red, is that little thin strand. So inside your element, where that filament is, you'll see some white powder. So that white powder is simply an insulator. It's there to prevent that thin fine wire inside from actually physically touching this outer casing. And that's important because if this has got all the power going to it and it can touch that outer casing, then suddenly the outer casing is being electrified and you're going to get a short circuit and blow a fuse. This is also, if that insulation over time, and it happens to bake elements and surface elements, that powder will start to break down and you'll wind up, instead of this thin filament being held securely right in the middle of the outer casing, it's now, with the powder moving out of the way or decomposing, now it allows this element to start to get closer and closer to the outer casing. And that's when you're going to see a really difference in color. So if your element's a cherry red and you suddenly have one spot that's a deeper red or a different color red than the rest of the element, that's a sign that your element's getting ready to fail. So if you're seeing that, now's the time to order that bake element so that you can change it before it lets you down, which is usually right around Christmas or Thanksgiving. That's when these things like to pack it in and leaving you in a bad spot. So if you're seeing that discoloration, you're finding that when you got the bake element on, or even the broil, or even your surface element, you're seeing one spot that's really a different color red than the rest, that element's starting to fail. The other thing that'll happen is sometimes this filament will just open up. It'll just wear out and it'll open up, it'll break the circuit, and you select your bake and the element doesn't come on, just dead. And you do your continuity test and you find that the element's the problem. Other times, we were talking about how the powder inside would kind of dissipate and this could get closer to the side and change the color. Well, if it can move close enough to that outer to actually short against it, it'll arc and spark inside to such an extent it'll actually start to open up this outer shell, and it'll almost be like an electric arc welder, and you'll start seeing sparks and flame and arcing and spitting of melted metal. If anybody's seen that, it's pretty scary. It looks like a lightning storm going on within your own oven. It'll do that for a while until finally the filament actually overheats and breaks, and that shuts the element off and stops that from happening. So sometimes it's just one little spot that'll spark and open up the element and just blow a hole in the element right there. Other times I've seen them actually follow right down the whole length or one leg of the element itself. Excuse me. So anyway, just a little bit of information on what's inside an element, what can happen, and what you can do to fix it. So Sarah, have you learned everything you needed to know about elements?
I think so. Actually, can you swap a bake and a broil element? Are they interchangeable?
A good question. So the biggest challenge in trying to swap elements out is, one, the physical size that they occupy in the oven itself. So if you change the size or type of element that you have in the bottom of your oven, you're going to change the cooking properties of that oven. The other thing to keep in mind is your broil element is a really hot element. So while this element may be 2,500 or 3,000 watts, your broil element's going to be even higher. It can be up to like 5,400 watts. So if you were to put a broil element in where a bake goes, it's going to just drive your heat up instantly and wind up burning everything just because it runs so hot. The general shape of them and the way they mount makes it pretty hard for you to make a mistake and swap a broil for a bake. But you know, if you need an element, your neighbor says, hey, I got an element here, you can see if you can put that in. You really got to make sure you got the right one, or strange things can happen. The other thing that happens to bake elements, and these little legs, so these little legs are on your element. This is what sits on the floor of your oven to hold the the element up off of the floor of the oven. Over time, some of these will get weak and fall and just basically lay down flat. So now your element is now basically laying down, touching the bottom of your oven liner. And that can give you problems as well. You're going to have hot spots there, you're going to heat the oven liner, probably wind up overheating the outer casing of the element and having it fail too soon. So if you find that the legs are loose and floppy, you want to change them. If it's to the point it's actually laying down in the oven and touching the oven liner, you want to replace your element. Now there are ranges out there today that you open your door and you look inside and you cannot see your bake element. Those are a hidden bake element, obviously, and depending on the manufacturer, some make it accessible by removing the floor pan of the oven liner. Other manufacturers, you have to access them either from the back of the range with the range back panel off, so you can see how it mounts in there and how you can pull it out of its position. Some manufacturers, actually, you have to remove the side panel of your range and in order to remove and replace that element. So it just depends on your make and model. Your parts breakdown will certainly give you information on where you're going to go look to find where your element goes. So they're a little bit more involved to change. Some are much easier than others, and some manufacturers it's not a lot of fun. But if you just take a look at the parts breakdown, see how it's set up, and just take your time and patience, you'll see how it comes out of there and how reasonably easy you can change it.
This would also be a good time to mention, don't put tin foil on the bottom of your oven.
Oh, excellent, Sarah. So Sarah's absolutely right. And from doing service calls, I would come across this an awful lot, and I would wind up in arguments with the customer. And you never wanted to argue because it's their home. They do what they want to do. But anytime I would be in to see a customer for a range problem and they were having a temperature issue or whatever with their oven, if I noticed that they were using a tin foil tray or just tin foil itself in the bottom of the oven, I would strongly suggest that they not do that. So the main reason, especially if you're a baker and you're doing short cook items like cookies and stuff, that tin foil will reflect heat. And when the bake element is on, you'll notice how they turn a bright red. Well, the moment that element's turning bright red, it's not only giving off this regular type of heat that you get from an element, but once it turns cherry red, it's now starting to give off infrared heat. And that extra heat is now going to be starting to bounce off of the metal liner. So if you've got tin foil in there, it's reflecting that infrared heat up into where your product's being baked, and you'll find you get uneven baking. You'll find they get black or brown on the bottom and yet not cooked on the top. So tin foil is great to have under your element in order to catch any spills or messes, but it affects your oven temperature. It can affect the heating cycle, throws your thermostats so that they're a little wonky. It's like your oven's not set for what it is really set for. And the other thing you have to watch is on those ranges, and this is what Sarah was alluding to, on those ranges that do not have an element that you can see, it's just this pretty smooth porcelain style bottom, easy to wipe up. They're just awesome. But for those who always had tin foil in the bottom of the range, or they don't want to have to worry about any kind of a mess getting on the liner, so they put the tin foil in place, with the hidden bake element, heating the oven liner from underneath, it will actually melt that tin foil and bond it directly to the oven liner. So at some point you'll open up your door and you'll say, you know what, that tin foil's now looking pretty bad, I need to change it. You'll go to pull it out and it doesn't want to let go. So you'll give it a tug and the tin foil will rip. You'll get probably majority of the tin foil to come off of the oven liner, but you're going to find there's going to be tin foil that's literally bonded to the liner and you won't be able to get it off. So that creates a couple of problems. One, you've got the stuff stuck to your liner that you can't get at it. Now you've got a situation where if you use self-clean, there's parts of the oven that's not going to clean properly because that liner is the secret to self-clean. Besides the high heat, it has a coating so things don't stick to it. But melted tinfoil bonded to that liner, it's very, very hard to get it off. Almost in some cases impossible. Now, some manufacturers give you a bottom panel in the bottom of their oven that can be replaced. So in that case, a few screws and a new part and you're back and everything's clean and looking good again. Other manufacturers don't do that. They have a one-piece oven liner that goes completely around like a box, and if you have your tinfoil melted onto that, you have to replace the whole entire liner, and that is a job and a half. And just to make the situation a little bit more worse, is some manufacturers do not make the oven liner available to service people, to customers. They consider it a non-serviceable part, so now you have to live with the condition the way it is, or if it bothers you that much or you're having a lot of issues as a result, you have to go and buy a new oven. So as much as the tinfoil adds that extra protection from spillovers, in a hidden bake element scenario, don't do it. Don't put the tinfoil. You're just going to be disappointed in the results. So, any questions out there in regards to ranges or any other appliances?
Nope, still a quiet crowd.
Alrighty, well, there's nothing wrong with that being a Friday, and everybody's got lots to do in order before we're getting into the weekend. But this information will be available to you later on, so if you want to come back and look at it again, or you want to share it with some of your friends or somebody you know that's having trouble with their surface elements or bake elements or broil elements, how to test them, how to understand what they do, and some of the things that you can diagnose yourself just by looking at them in operation. Just send a link along from this, and they'll be able to see the same information that you guys did. So,
all right. Thanks for joining, everyone. We'll be back in a couple weeks.
Yep.
It's not too soon, but we're going to be talking about snow blowers.
Yeah, an awful thought. Frost here this morning, so we know that it's not that long before we're going to be needing to get out that snow removal equipment. So we're going to be doing some videos and some lives on how to look after your snowblower and make sure it's ready to go. So we hope you'll join us for that. Until then, thanks very much, and we'll see you next time.
Enjoy your weekend.
Bye now.